All right, so we're going to talk about these things called projectiles. A projectile is anything that is falling under the influence of gravity. So we've already talked about that once. Quadratics are useful for that sort of stuff, anything pertaining to gravity. So we'll talk about how you can use quadratics to find the height of a projectile. Specifically, we'll be looking for the maximum height and how long it takes for it also to land. So we're going to see how quadratics can be useful for that. So what is a projectile? A projectile is an object falling under the influence of gravity. So in the first picture here, we have somebody who's just dropping something. That's considered a projectile. Someone throwing something straight up or something throwing it outward a little bit. The last one shows that you can kind of see kind of like a parabola going on there. But technically, the other two can be modeled with quadratics and parabolas also. Now, this comes from physics and calculus, but there is a quadratic formula that represents the height of a projectile at any given time, and here it is. So this represents the height at time t, and you guys should probably write this in there. So if you wanted to find, so basically what this is a formula where you could plug in any time value and it will tell you the height of the projectile at that point in time. So if you were to plug in like 3 for time, 3 seconds we'll say, then this formula's answer that it would give you after you plug it in will tell you how high the object is, what its height up in the air is at that point in time. So that's what it does. Time, I'll draw an arrow to the t. There's 3 places that you have a t in this formula. Time is going to be measured in seconds for today. We could do it with other units, but we're going to stick with seconds. This little circle here that's next to the V, it's pronounced not. I'm not sure how to spell it though. Shame on me. I don't know how to spell it. I don't think it's N-O-T, but this is V naught. But what that means is that means the starting amount. So anytime you're in math or science, if you see a letter with a little 0 next to it, that means a starting amount for that variable. The V represents velocity, and since there's a little 0 next to it, this is the starting velocity. Starting velocity. Also known as the initial velocity. I could put that word in there if you don't flesh it. If you don't know what the word initial means, you might want to write that down because they'll be saying that word in the paragraphs today that we're reading. So when you throw an object, right, it has a starting speed. Eventually it's going to slow down. You know, the faster you throw it up, right, that's the initial speed, but gravity pulls on it and it gets slower and slower until eventually it stops and it starts coming back down. Velocity is like speed, but it also tells you direction. If you have a positive velocity, that means it's moving up. Negative means down. So when I throw it up like this, it has an initial velocity that's positive, but on its way down, it has a negative velocity. So velocity is speed, and the sign indicates what direction it's going. Okay. Now we're only going to look at objects that are going in like from an initial velocity that's upward. I'm not going to talk about throwing an object downward. That would be a negative velocity. We won't look at that today, just upward. What do you guys think that is? Good. What kind of height, though? That's the initial height, the starting height. So that little h there represents a height, but a special height. It's the starting height. So starting or initial height of the object. So basically, if you know how fast an object is thrown, and if you know how high up off the ground it was when you let it go, you should be able to use this formula to find out the height of that object at any point in time. And that's what this formula is for. You might be wondering what this 16 here is. You don't need to write this. You can if you want to, if you like science and you want to know. But what this is the acceleration due to gravity. Once again, some scientists, mathematicians came up with this formula. You don't need to write this because that 16 is just going to be there the whole time today, but if you're curious why it's there, that number is the acceleration due to gravity. Basically, objects fall towards Earth, so it's negative. They fall towards Earth, downward direction, at a rate of 16 feet per second, which means every second that goes by, it's going 16 feet per second faster. So that's the acceleration due to gravity. But anyway, so this one over here represents our height at any time we choose to plug in. This one represents our starting height. This is our starting velocity. The t represents time. Now, some things to keep in mind. If an object is launched from the ground level, that means your starting height would be what? Yeah. So if you're launched, so like, well, maybe let's talk like a golf ball, right? When you hit a golf ball, it's coming off of the ground, so the starting height would be 0. When an object lands on the ground, that means its final height is 0, right? Not its starting height, but its final height. I want to talk about when it lands on the ground. Well, that's when this piece over here is going to be equal to 0. So if it starts from the ground, h naught is 0. But when it lands on the ground, h of t equals 0. That's the final height. That's the starting height. Right? So we will see some problems today where we set the final height equal to 0 and we solve for time to figure out how long it takes to land on the ground. Okay, so that's that. This is a pretty calculator-heavy day. So we'll be using some calculators for a lot of this stuff today. So as you guys may recall, this is a y-intercept. This is a vertex. And the vertex has an h and a k in it. And this is a root. But in our story problem today, all these things are going to be something. So what does the y-intercept represent in today's story problem? Starting height, right? That's the starting height. What do you think that the root represents? The final height, or the place where it lands, right? So the final height is equal to 0, or when it lands. So today, when I ask you, how long does it take for this object to land on the ground? That's just a word problem way of saying find the roots. Okay. Up here, the vertex, this one is going to be a time value, and this is going to be the maximum height. So when I ask you guys to find the vertex today, the t tells you how long it takes to get to the top, and the y value tells you what the top value is. So when I ask you how long does it take to reach the maximum height, I want you to find the t value of the vertex, or the x value. And if I ask you what is the maximum height, I want you to find the y value. So let's write that. How long it takes to reach the max height. And this is if you want to find the max height. Okay, bonus question for you guys. Does anybody remember how to find the x part of a vertex? Mm-hmm. Great job. So if I ask you today, how long does it take to reach the maximum height? You're going to use that formula right there. Okay. How do you find the y value of the vertex? you plug your h in over here to your function, and that'll tell you what the height is. So you'll take your function, h of t, and you'll plug in negative b over 2a. Okay. So I'm going to ask you guys 3 questions today. 3 questions. One of the questions I'm going to ask you today is, how long does it take to reach the maximum height? So for that, you use that formula there. Another question I'll ask you is, how do you, now let's find the maximum height. You're going to plug that into your function to find your maximum height. It's basically the same thing as finding the vertex of a quadratic. The last question I'll ask you is, how long does it take to land on the ground? For that, I'm asking you to use the find the roots. How do we find the roots of a quadratic? True. What else? There you go. So that's our lesson. That's our whole lesson today, all up there on the board. So if I ask you to find the max height, use that. And if I ask you to find the roots, use that. Okay. So that's our whole lesson in one picture. Is anybody still writing this stuff? I'll pause for a sec. So just as a fair warning here, Dave, I'm going to do something a little bit different than I usually do. What I usually do is I do a problem, and then I let you guys practice, and I do another problem and you guys practice. I'm going to do all of my examples up front, and then I'm going to let you guys do all of yours at the end. So one big lecture and then one big practice session. Just be aware. I'm going to talk for a while. Take good notes, pay attention, and then you'll use what I write for you to help you with your set at the end. All right, so here we go. A bullet is fired straight up into the air from an initial height of 6 feet with an initial velocity of 900 feet per second. So our first question on our worksheet says, write a quadratic function that models the bullet's height. Well, most of that work's been done for us by scientists and mathematicians. They figured out this is the formula. So I'm just going to rewrite that there real quick. But we have some numbers to plug in there. Okay? So they tell me that my initial height, so let's circle that. My initial height is 6 feet. Initial height is this one. They also tell me that my initial velocity, that's this one, is 900 feet per second. So all I need to do to write a formula for this height of the bullet is I need to plug in those two things. I'm going to plug in 900 for the initial velocity, and I'm going to plug in 6 for the initial height. So that's the answer to question 1. So you can't do any of the other work unless you do that. So step 1 is to plug in your initial height and initial velocity so that you have a formula. Oh, you're sharing. Okay. So same story problem here. How long does it take for the bullet to reach its maximum height? So let's put a dot right here. And this is how long. The x part of the vertex tells us how long it takes to reach the maximum height. That doesn't tell us what the max height is, it just tells us how long it takes to get there. And as Denise shared with us earlier, we use this little formula to find out how long it takes to reach the maximum height. So it's going to be negative b over 2a. I'm going to write my formula down up here again. You don't have to because it's already on your paper, but I'm going to rewrite it myself here. 16t squared plus 900t plus 6. All right, so we do negative b over 2 times a. My b value is 900 my A value is negative 16. So that's negative 900 divided by negative 32. And what we're going to do is we're going to divide that. So would you guys go ahead and do negative 900 divided by negative 32? And what we're going to do is we're going to round it to the tenths place, the first number after the decimal. Yeah. 28.1. Okay. What does that answer represent? How long it takes to reach the maximum height. So that's 28.1 seconds. Now, just so you guys know, this problem, I picked realistic numbers. I remember when I made this lesson a few years back, I picked 900 feet per second is not an unrealistic amount for a bullet being fired. The problem is that our answers are going to come out a little off, and that's because in reality there's air resistance, which causes things to change a little bit. So this is kind of like what would happen if there was no air or friction affecting the bullet. It would take that long to reach its maximum height. Now in reality, it would probably reach its maximum height a little bit sooner because air is like pushing against it. But we're going to ignore that for today. So for now, 28.1 seconds. Okay. So that's how long it takes to reach its maximum height. So our next question is, what is the bullet's maximum height? So that's this one. The y value of the vertex is the max height. And what we said about that was to find the max height, we're going to take our height function up here and we're going to plug in the time that we just got, which is 28.1. So let's use our calculators and do that. Let me write it out first though. So h of 28.1, I'm just going to plug in 28.1 on my calculator. Now, you guys should be able to type this in exactly the way that it looks on your calculator. You shouldn't have to do it piece by piece. You should be able to type the whole thing in and just get an answer. It saves you time. I'll walk you through it if you don't know how to type it. But go ahead and finish writing, and then I'll explain how to type it in. But it's pretty self-explanatory. The only thing that might be weird is the square. I get this after I plug it in. And what does this represent? Okay, yeah, that seems extremely unrealistic, just so you know. I wonder if I did something wrong. It seems really odd. You got that too? Okay, yeah, that's what it is. That's extremely unrealistic, just so you know. That's really high. But we're going to leave it. So that's the idea. So it takes that long to reach the maximum height. And we're going to say that's what the maximum height is. Oh, did I put the comma in the wrong place? Yeah, it's still really high, though. It's like 12,000 feet. That's like more than 2 miles in the air. It doesn't do that. Once again, that's because of air resistance. So that's what would happen without air resistance, but air resistance would not actually allow it to reach that height. All right, so there's that. So we've answered 2 of our questions so far. There's only one more that we need to answer, and then we'll let you guys practice. But question 1 is, how long? Question 2 is, what is that height? Our last question is, how long does it take to land on the ground? Okay. Let's do one more question here. How long does it take to land on the ground? Now, there are, on a quadratic, you guys, it does touch the x-axis twice. But if I'm asking you how long it takes to land on the ground, which one do I want? I want the one on the left or the right? I want the one on the right. This one, a lot of times it'll just be a negative number anyway, and we don't care about that. I want this one on the right. So you guys know when you do the quadratic formula, which is what we're going to do to find the roots, you get a plus and a minus problem. Well, whichever one gives us the biggest answer is the one that we're going to keep. And I'm pretty sure it's the minus one every time. So we get a plus and a minus. You're going to keep the minus one. That one's going to be the one that actually turns out positive in the end. So I'll show you when we get there. So anyway, I'm going to rewrite this up here one more time because I need to see it. You don't need to rewrite it. All right. So how long does it take to land on the ground? Well, that's right here. That's where h of t equals 0. So I'm going to replace h of t with 0. Just like that. Well, I've got a quadratic equation in standard form equal to 0. When you have that, the way that you solve it is with the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So the good news is that this will be a little bit easier than the last time we did quadratic formula because we're going to let the calculator do all the work for us. You still got to watch your order of operations a little bit. But. So 900 goes here and here. A goes here and here. And C goes here. All right, let's do the bottom here. We have 2 times negative 16. That's negative 32. All right. We could probably type this whole thing in on our calculator, okay? Or you can do it piece by piece if you want. But I'll show you guys how to type it all in on your calculator at once. And it's going to come out to be a decimal. It's not going to be a perfect number. We should be able to type it in exactly the way it looks here. Exactly the way it looks. So where you see a parenthesis, you're going to put a parenthesis. Where you see a square, you're going to put a square. You have to be careful. This one here is a minus sign, and this one here is a negative sign. And remember, on the calculator, your calculator sees those differently. So let's go ahead and type this stuff in and do it together here. So first of all, let's get the square root on there. The square root is right above the x squared symbol on your guys' calculator. So to get that, you're going to push second, and then you're going to push that button, and you should have a square root on your screen right now. Looking good? All right, now parentheses, 900 parentheses squared. Go ahead and type that in on your calculator, parentheses, 900 parentheses squared. Now the next thing is a minus. It's not a negative. That's a minus 4ac. So we're going to do minus, which is this blue button here on the right side, minus. And then you're going to do 4 parentheses, negative, that's this one. Negative is down here. Negative 16 parentheses, 6 parentheses. And enter. See what you guys get. I'll type it out too and see if I agree with y'all. So I get 900.2. 900.2. So if you didn't get that, maybe let me know during student practice and we'll see what happened there. But I get about 900.2. Okay. After that, we're going to write out 2 equations. We're going to have negative 900 plus 900.2 over negative 32, and negative 900 minus 900.2 over negative 32. Now, as I mentioned to you guys, remember, quadratic form is going to give you 2 answers, right? But we only want 1 answer. We want the bigger one, the one that's on the right. Well, the one that's going to always be the one we keep is the bottom one. The top one, we won't, the one with the plus, we won't be keeping that one. Yeah, but you know, I'm going to handle this a little bit differently. But yeah, you're right. But I'm going to handle this one a little bit differently. So So we'll just get rid of that now. We don't need to simplify that. That would be this root over here, and I don't care about that root. I want to know the root on the right, so we're going to use the one in the minus. So let's do that. On your calculators, do negative 900 minus 900.2. Now remember, that's a negative 900, and that's a minus. So don't get those mixed up. Negative 900 minus 900.2. You guys should be getting negative 1800.2. Right? Now last step is to do your division. Divide that by negative 32. You should be getting 56.3. And what does that represent again? No, the final height is 0. That's how long it takes to do what? Hit the ground. So that's the landing time. So it takes almost a minute. Once again, it's not horribly realistic. The best I could pull off, though. So 56.3 seconds is how long it would take to land on the ground. I wonder what a real answer would be. I'll look that up. Anyway, that's it. Those are the 3 questions I'll ask you. How long does it take to reach the maximum height? What is the maximum height? And how long does it take to land on the ground? Okay? On the back of your sheet is your guys' work. So go ahead and work on the back side for the remainder of class. And that'll be it for today.